So the function is f of x equals x squared over x minus 1. And the directions are to find the local max and min values of f using both the first and second derivative tests. Which method do you prefer? Okay, so the first method we're going to try is the first derivative test. Okay, so the first derivative test is we're going to take the first derivative. So, so what is the first derivative? What rule do we need to use? Quotient rule. So to the quotient rule, you're going to take the denominator, x minus 1, times the derivative of the numerator, which is 2x, and then plus or minus? Minus. Good. Somebody on the test did plus. Okay, so first derivative, or denominator times derivative of the numerator minus numerator times derivative of the denominator is 1. All over the denominator squared. Okay, so the first derivative then is going to be, we're going to distribute this 2x through, so we get 2x squared minus 2x, and then minus x squared, all over x minus 1 squared. So the first derivative, 2x squared minus x squared, is just x squared minus 2x all over x minus 1 squared. All right, so my critical points, my critical values are going to be wherever the first derivative is equal to 0 or where the first derivative does not exist. All right. So, where does the first derivative equal 0? So, in order for this first derivative to equal 0, what has to equal 0? The numerator, right? Because it's a fraction, so anything divided by 0 is undefined. I said that wrong. 0 divided by anything is going to be 0, right? So, if I want this whole fraction to be equal to 0, then that means that the numerator, x squared minus 2x, has to be equal to 0. Okay? So then to solve for what x values make that true, factor out the x that they have in common, and that leaves me with x minus 2. And then that means that either x equals 0 or x minus 2 equals 0. So either x equals 0 or x equals 2. So those are two critical values. And then we also want to look at, is there anywhere where the first derivative does not exist? Good. It can't exist where the denominator is equal to 0. Okay, so that we're going to take x, the denominator, x minus 1 squared, and we don't want that to equal 0. If we square root both sides, we get x minus 1 cannot equal to 0. And then add 1 to both sides, we get x cannot be equal to 1. Okay? All right, so if we put those critical values on a number line, we have 0, 1, and 2. All right, so that's where the first derivative equals 0 and where it does not exist. So then you're going to want to set up a chart with those intervals. So what's this first interval? Okay, so the intervals The first one is negative infinity to 0. The second interval is 0 to 1, and it doesn't include the endpoints. And the third interval is 1 to 2. And then the last interval, 2 to infinity. Okay, so we have 4 intervals. Then you're going to want to pick a test point in each interval. So what's a test point in negative infinity to 0? Negative 1. In 0 to 1, 1/2. 0.5. Between 1 and 2, 3/2 or 1.5. And 2 to infinity, 3. Okay. Then you're going to take those test points and plug them into the first derivative. And then we're going to want to see, what we're trying to see is that positive or negative? Okay. All right, so negative 1, if we plug that into our first derivative, f prime of negative 1 is going to be negative 1 squared minus 2 times negative 1 over negative 1 minus 1 squared. Okay, so positive 1 plus 2 is going to be positive 3 over negative 1 times, or negative 1 minus 1 is negative 2, and then square that is 4. So is that positive or negative? 3/4 is positive. Okay. All right, then plug in 1/2. Okay, so f prime of 1/2 is 1/2 squared minus 2 times 1/2 over 1/2 minus 1 squared. Okay, so I didn't leave myself enough room here. That's okay. F prime of 1/2 then is 1/2 squared is 1/4 minus 2 times 1/2 is 1, so minus 4/4. So I'm going to go ahead and make that 4/4. Okay. Bless you. 1/2 minus 1 is negative 1/2 squared is positive 1/4. Okay, so in the numerator, 1/4 minus 4/4 is negative 3/4. And then flip and multiply the denominator, 4 over 1. So we get negative 3. So that is negative. Whoops, that's not. Okay, I really didn't leave enough room here. So f of 3/2, we'll just do it down below here. So f of 3/2, f prime of 3/2 is going to be 3/2 squared minus 2 times 3/2 over 3/2 minus 1 squared. So that's going to be 9/4 minus 6/2 over 3/2 minus 1. So you're going to have to multiply that by 2 over 2. So 3/2 minus 2/2 is 1/2 squared. Okay, and then multiply 6/2 by 2 over 2 to get a common denominator in the numerator. So that's going to be 12 over 4. So 9 minus 12 is negative 3 over 4. Over 1/2 squared is 1/4. So flip and multiply. So negative 3/4 times 4 over 1 is going to be negative 3 also. Okay, so that's negative. So that's for the interval 1 to 2. Okay, then the interval 2 to infinity, we're going to plug in 3. So f prime of 3 is going to be 3 squared minus 2 times 3 over 3 minus 1 squared. So 9 minus 6 is 3 over 3 minus 1 is 2 squared is 4. So that's also positive. Okay, so positive, negative, negative, positive. Okay, and then we need to decide, okay, with the first derivative test, we can decide whether it's increasing or decreasing by whether it was positive or negative. So for negative infinity to 0, the first derivative is positive, which means that on that interval it is increasing. From 0 to 1, it was negative, so it's decreasing. From 1 to 2, it was negative, so that's also decreasing. And then from 2 to infinity, it was positive, so that's increasing. Okay, so then to find whether it has a max or a min, where it goes from increasing, so it's going uphill, to decreasing, what does it have there? A max, a local max. And where is that local max going to be at then? At x equals, what's in between those two? Look at your interval. Between, so it on the interval from 0 in negative infinity to 0 is increasing. Then from 0 to 1, it's decreasing. Okay, so increasing to decreasing, right there at x equals 0, there's a local max. Okay, so it's the x value that's on the ends of either one of the intervals. All right, then between 0 and 1, it's decreasing. And then it keeps on decreasing from 1 to 2. So it's still decreasing. So if it's decreasing and decreasing, there's no local max or min there. At x equals 1. Okay, and then so that's between those two, and then between those two there's no max or min. So then the last two, between 1 and 2, so it's decreasing, decreasing, and then increasing. So only where it changes from increasing to decreasing, or from decreasing to increasing, what's there at x equals 2 then? Local min. Okay, so local min at x equals 2. Okay, so we can find what that max and min value, the local max and local min values are by plugging back into your original function. So f of 0 equals 0 over negative 1, which is 0. So 0, 0 is the point that's at that local max. Sorry. Okay, and then same thing, the local min is at x equals 2, so plug that back into your original function to find the corresponding y value. So 2 squared over 2 minus 1, 4 over 1 is 4. So the point 24 is your local min. Okay, so that was the first part, because it said to find it by the first derivative test, and now we're going to do the same problem using the second derivative test. We're finding our local max and min by our second derivative test. Okay, so the second derivative test. Okay, so our original function is f of x equals x squared. F of x equals x squared over x minus 1. And then we found our first derivative, which was, our first derivative was f prime of x equals x squared minus 2x over x minus 1 squared. Okay, so that's the first derivative. And then how do we find the second derivative then? Take the derivative of the first derivative. So again, what rule do we need? Quotient rule. So you're going to take the denominator, x minus 1 squared, times the derivative of the numerator, which is what? 2x minus 2, plus or minus? Minus the numerator, x squared minus 2x, times the derivative of the denominator. So what rule do we have to use to do that one? Chain rule. Okay, so you take the outside function, 2 times 1 is 2. Everything stays the same on the inside. To the decrease that power by 1, so that's going to be to the first power. And then the times the derivative of the inside, which is 1. Okay, and then all of that over the denominator squared. Okay, so simplify that a little bit. So we can multiply everything out in the numerator. So this is x minus 1 times x minus 1. And then that answer will multiply by 2x minus 2. So let's go ahead and multiply x minus 1 times x minus 1 is x squared minus x, so minus 2x, and then plus 1. And then we're going to take that and multiply it by 2x minus 2. And then minus, over here, we have x squared minus 2x. And then times, distribute this 2 through, so we get 2x minus 2. All over, so since you're squaring a square, that's going to be x minus 1 to what power? To the 4th power. All right, then multiply, distributive property for this first term. So x squared times 2x is 2x cubed, 3 x's. And then x squared times negative 2, negative 2x squared. Then negative 2x times each one. So negative 2x times 2x is negative 4x squared. And then negative 2x times negative 2, negative times negative, positive 4x, good. And then positive 1 times 2x. And positive 1 times negative 2. All right. And then minus, and leave this in parentheses until you finish all of the multiplication over here, and then we'll distribute the negative. So x squared times 2x. We're going to leave the negative out in front to start with here. So x squared times 2x is 2x cubed. Then x squared times negative 2, negative 2x squared, and then negative 2x times positive 2x, negative 4x squared, and then negative 2x times negative 2 plus 4x. Good. All over x minus 1 to the 4th power. All right, so we get 2, and I'm just going to go ahead and distribute this negative through up here on top. So this is going to be negative 2x cubed plus 2x squared plus 4x squared minus 4x. Okay, now let's go ahead and combine like terms in the numerator. So I have a 2x cubed and a minus 2x cubed. That's 0. Any more x cubes? No. Then I have a minus 2x squared and a positive 2x squared, so that's 0. And then I have a negative 4x squared and a positive 4x squared, so that's 0. Any more x squareds? I think that's it. Then I have a positive 4x and a negative 4x, so that's 0. And then I have a 2x and minus 2 all over x minus 1 to the 4th. Okay. Then out of the numerator, I can factor out a 2, so what's left? X minus 1. And then that will divide out with one of the x minus 1's in the denominator. Don't you love it when all this stuff cancels out? It's the beauty of math right here. Okay, so 2 over x minus 1 cubed. Nice and tidy. All right, so that's the second derivative. So then remember the second derivative test says, if you look back on page 225, the second derivative test says that if the first derivative is equal to 0 and the second derivative is greater than 0, then f has a local minimum at x minus c. Okay, so if you think about when we did the first derivative test, here from negative infinity to 0, the first derivative was negative. From 0 to 1, the first derivative, positive. From 0 to 1, the first derivative was negative. From 1 to 2, negative. And from 2 on, it was positive. So that was the first derivative of x for those intervals. Okay, so now we need to find the critical value for the second derivative so we can see where that fits on our graph here. Okay, so you want to find where the second derivative is equal to 0 or where it's undefined. Is there anywhere where it can equal 0? No, because it's a fraction, and the only way that fraction is going to be equal to 0 is if the numerator is equal to 0, right? So it can't equal 0. Where is it undefined? Does not exist where x minus 1 cubed is equal to 0. Okay, so that would give me what? Take the cube root of both sides, we get x minus 1 equals 0, add 1 to both sides, so x equals 1. Okay, so if you think of that on a number line, x equals 1, to the left, find a test point. So this is negative infinity to 1, and this is 1 to infinity. So find a test point in negative infinity to 1, 0. And in 1 to infinity, 2. Okay, so plug that into the second derivative. So f double prime of 0 is equal to 2 over 0 minus 1 cubed. So that's going to be 2 over negative 1 cubed is negative 2. So negative, what does that mean in this interval? It is concave down. Okay, and then concave down. Okay, and then from 1 to infinity, the test point is 2. Plug that in. So we're going to get f double prime of 2 equals 2 over 2 minus 1 cubed. So 2 over 1 cubed is 1, so just 2. Okay, so since that's positive, in this interval from 1 to infinity, what does that tell me about the concavity? Concave up. Okay, so really without even looking at the first derivatives, we can tell that there's going to be a local max and a local min, right? But then if you go back and look at the first derivatives, okay, so in this, so this from 1, here's our second derivative. Our critical value was 1. Okay, so from negative infinity to 1, it was, the second derivative was negative. Okay, and from 1 to infinity, the second derivative was positive. Okay, so the second derivative test says if the first derivative is equal to 0, so that's at the point x equals 0, and the second derivative is positive, so we had the values where the first derivative was equal to 0 is here at x equals 0 and at x equals 2. Because we took the first derivative, set it equal to 0. Those are the two values where x is equal to 0. And then, so the second derivative test says if the first derivative is equal to 0 and the second derivative is positive or greater than 0, then f has a local minimum. So local minimum at that value where x is the first derivative is equal to 0. So local minimum at x equals 2. And then it says if the first derivative is equal to 0 and the second derivative is negative, then there's a local max at x equals 0. All right, so that's the